I'm going to walk you through how to complete this assignment. Okay, let me share my desktop with you. Chat box. Yes. Okay. My desktop. Can you guys see my desktop?
Yeah, I can.
Okay. I assume that everybody else can see my desktop. So, first question. It is all about Dow Jones Industrial Average over a period of time. What kind of question could that be? When we talk about a variable or when we monitor a variable over a period of time. Let me first ask this question. Have you guys been able to install Decision Tool Suite on your computer?
Yeah, I've got that installed already.
Okay, yeah, great. What about other friends?
Yeah, I just checked. It looks like I got it downloaded. I hope it's the right thing though.
Okay, yeah. Actually, our department spent, I think, something over $1,000 to install it on our workstation. But under current circumstances, as I said before, I talked to the Palisade company, and they accepted to give us free license for your own computers. All right. So it should be that should work on your computer without any problems. So let's go to this question. Okay. Let's see how we can handle this question. These three paragraphs, these are all about Dow Jones Industrial Average. From these three paragraphs, I want you to get a sense of the variable. Our variable is a time series because it's just a variable with different values over a period of time. So we are monitoring one or a few variables over a period of time. This is called time series. Most of the stock indexes are called time series data. So now we want to see how we can summarize this information. Use the summary measures and graphical tools for this from this chapter. Analyze the important time series over the given period and summarize in detail the behavior of the monthly closing value of the Dow Jones and associated monthly percentage change in closing value of Dow Jones, DJIA. Okay. Let me check the chat box. Stat tool does not appear on my banner. You need to run it from your desktop. You need to click something like this icon shows up on your desktop, and you need to click on that. And if it still doesn't work on your computer, you need to go to the file option, add-ins, and then go and then check that package that you need, like stat tools and risk. These are two software tools that we need for this course. You need stat tools at the bottom and the risk. Okay. Let's go through this together. So we want to calculate the summary measures. You know that by summary measure, we mean summary of central tendency, like average, median, mode, and also the distribution, like a standard deviation and variance. And also we want to report the shape of the distribution, kurtosis and skewness. Okay. You can simply go to stat tools. In stat tools, first we need to define our data set, our data range. So you need to click on this data set manager. New. Data range. We select all these variables, Control Shift down. You will go to the end of the data set. So it is going to be our data set. Now we want to get these summary measures, like central tendency, distribution, shape, and etc. for these two variables. The first variable is date, and we have two variables, closing value and also percentage of the change. So you need to go to the summary statistic, one variable summary, for example, for the closing value, one variable, closing value, we can get all the report for all these variables or measures. Here you see the mean, variance, standard deviation, kurtosis, skewness. It is skewed to the right because its value is bigger than 0, and it is positive. It means the shape of the signal is not symmetric and it is skewed to the right, which means its right tail is bigger than its left tail. So skewness is about symmetry. So the other way to put all these three variables together is to go to the time series and forecasting. One way is to get the report from summary statistic and get the report for all these variables one by one, or you can put these variables together in a time series forecasting. Okay, here you can get the time series graph. And let's get the report for the other variables, like percentage of the change. For the second variable, mean is this value, variance, standard deviation, median, and again, skewness. Here for the percentage of change, the shape of the signal, the distribution must be skewed to the left because it is negative. And you also, you can compare the mean and median. And if mean is bigger than the median, the diagram must be skewed to the right. So this way we can get the result for summary measures of one variable. Now we want to plot it in a time series graph. Okay. We want to check the trend of these values over time. See if it shows on your downloads, because mine does. I just think I have to go through, and sometimes with the files after class.
Yeah, what I meant by that is like mine shows up in my downloads that I have it, but it's not showing up on Excel. So I think I have to mess around with the files and probably like restart my computer and that. So that's why I was kind of explaining to him.
Oh, okay. Okay. I thought it was a question for me. So format time series, we select time series with label. Our label is going to be the month because we want to monitor those two other variables over time. So the label is going to be the month. Values, we want to monitor these values, closing value and etc. Okay, let's see what we get. Look at that. This upper diagram shows the trend of Dow Jones Industrial Average from, for example, January 2005 to April 2015. This trend from this time, from January 5 to June 2018 has a kind of steady rise. Here we have some whiplash, and in April 2015, it reaches its top, 18,000. And this diagram, the lower diagram, shows the changes in the percentage of change in the second one. This way we can monitor the value and the changes in time series data. Let's see. Okay, we got the summary measures, summarize in detail the behavior of the monthly closing value and associated monthly percentage in closing value of Dow Jones. Okay. Is there any question about this, about first question? And there is another diagram that we can check and get the report regarding the shape of our signal. Summary graph, histogram. Histogram is used to check the skewness and shape of our signal, our data. For example, for the percentage of change. Okay. Let me first show you the report for the percentage of change. Closing value, no. This one is percentage of change, okay? Here you see the summary measure for this variable. Its mean is 56, 57, 100 or 1000. Mode, median is 00857, and it has to be skewed to the left because its value is negative. Now we want to check its shape in a histogram. Now, let's check the histogram of the percentage of change. Histogram, we want to check this value, percentage of change. Okay, do you see? It is relatively skewed to the left. It's not a perfect symmetric shape. And you can get all the result for this variable, for the percentage of change. And you can do the same for other variables to see their distribution, their summary measures like mean, median, mode, variance, and also check its shape. That's how we should answer the question 1. I expect you to get this report and include it in your submission. Let me close these files. Is there any questions from this part? Don't save. Okay, let me close this file and go to the next question. Second question, P235 contains data from survey of 500 randomly selected households. Indicate the type of data for each of the variables included in the survey. So for part A, you need to determine whether the variable is categorical or numerical. And if it is numerical, whether it is ratio or interval. And if it is categorical, is that a nominal or ordinal variable? Okay. So the first variable, household, what kind of variable do you think it is? No answer? Okay. The first variable is a nominal variable. It is just a number, and it is just a kind of label to identify our records or observations. These columns are our variables, and these rows are observations. Okay, so this number 1 identifies, it's a kind of identifier for this observation. Number 1 is the identifier or ID number of this record, this observation. So household is a nominal variable. Family size is a numeric variable, number of people in a household. Location, it seems to be numeric, but it is actually a categorical variable. Okay, categorical, and it is just a label. The different locations have been encoded by a numerical variable. This is called a dummy variable, a categorical variable that has been encoded by numerical. So it is a, again, it is a nominal variable. Ownership, it has two states, whether you can either own or not own, 1 or 0. It is again a nominal variable, nominal categorical. Income is a numerical, and it is a ratio. Second income is a numerical. Utilities, numerical, and debt, again, it is a numerical variable. Is that clear so far?
Yeah, it's clear.
Okay, so let's see what question asks for. Indicate the type of the variable. Okay. Part B, for each of the categorical variable in the survey, indicate whether the variable is nominal or ordinal. You already answered that. C, create histogram for each of the numerical variable in the data set. Indicate whether each of these distributions is approximately symmetric or skewed. Okay, so we have already identified our numerical variables. Family size, first income, second income, monthly, utility, and debt. We need to draw and plot a kind of histogram to see if it is skewed or not. You can also check the summary measure to see if it is skewed or symmetric. So first we need to stat tools. We need to define our data range from dataset manager. Click OK. And then we go to the summary graph, histogram. Let's check, for example, first income, which is a numerical variable. You can get the report for all other variables by clicking all these variables. Let's get the result. Okay, so histogram of the first income. It is skewed to the right. Its right tail is longer than its left tail. So this variable, first income, is not symmetric. It is skewed to the right. And for other variables, again, it is skewed to the right. Histogram of monthly payment, it is skewed to the right. That's how you check the symmetry of a variable. Part D, find the maximum and minimum depth level for the household in this sample. So we need to check the depth level, maximum and minimum. We go to the summary statistic, one variable summary. We want to check the maximum and minimum value of the depth. We uncheck all these variables. We don't need them. We just need the maximum and minimum. Okay. Here is the report. Minimum depth is 227 and maximum depth is 9,104. This is for the part D. Part E, find the in-depthness level at each level of 25th, 5th, and 75th percentile. Again, we go to the summary graph, summary statistic, and we get the first quartile, third quartile, and it also asks for third quartile or 75th percentile. Okay. First quartile and second quartile. Is this, it is calculated this way, and we can check the percentile here. We want to get the 25th, 50 percentile, and 75th percentile. Okay, you need these three values: 25th percentile, 50th percentile, and 75th percentile. And here's the values of those variables. Is that clear so far?
Yeah, that's clear to me.
Okay. What about
Isn't
other books?
50 the 50th percentile, isn't it also the median?
No, it's not about median. Median is when you sort. Yes, 50th percentile is exactly the median, right? When you sort the data from smallest to the largest, so 50th is going to be exactly in the middle.
Okay, because that was my question as well, and I answered.
Yeah. Okay. So F, find and interpret the interquartile range for the in-depthness level of this household. Interquartile range. Okay. Again, we go to the summary statistic, one variable summary. Oh, let's see. I got an old computer, it always crashes. Let me close all these files and open them again. Okay. We were working on this file, P235. Okay, stat tools. We want to get the interquartile range for debt. Interquartile range is the difference between 75th and 25th quartile. Oh, first I need to define the data set. And now we can get the interquartile range from stat tools. Summary statistic, one variable summary. Therefore, we need to select depth interquartile range. Okay, 2,743, which means 50% of our population fall in this range. Between 25th and 75th percentile fall in this category. The majority, or the 50% of the population or our observation, fall in this range. That's the difference between 25th percentile and 75th percentile. Does that make sense?
It makes sense to me.
Okay. Does that work for everybody else?
Is that going to be like the same no matter what data set we're using? Is that just kind of like the general idea of the interquartile range?
Yes, the idea is the same, but the interpretation is that 50% of the data fall in this range. The difference between these two values is something around 2000 or something. That's how you should interpret the interquartile range. 50% of the observation fall in this range.
Okay, that makes a little more sense.
Okay. That's for question 2. Let's go to question 3. It contains price of gasoline in each of the 50 states. In each of the 50 states, compare the distribution of gasoline price data across the states. Okay. Specifically, are the mean and standard deviation of this distribution change over time? If, how do you explain the trends? So we have a lot of work to do in this data set. Okay. Let me copy data, create a copy. You want to keep the original table and then work on the second one. All right. So I'm going to delete these parts. You can highlight them, click right, and then delete the entire row. The same for this. Delete entire row. click delete the entire row. South, delete entire row. Entire row. And this last item. I got rid of all these extra rows. Now we have a consistent table. Let's see what it asks for. Compare the distribution of gasoline price across the states. Okay, first we go to Stat Tools, select our data range, the entire data set. Okay. We are monitoring these variables, this value of the oil price across the states over time from 1989 to 2008. So we can just consider if we want to see the price change across the states, we need to just consider the columns, these columns. Okay. So we can go to the time series graph, and again, label is going to be the time. Let me this is the values in different states. This is not across the states. We need to get the other report. dataset 1, new. Let me delete this one. Time series. Okay. Read labels. Okay. So this diagram shows how we can monitor the values in different years: 1989, 1990, 1991 across the states. And we get the distribution and how it rises or falls. This is for the first part of the question. In which region of the country have gasoline price changed the most? We can, to check the changes, we need to get the report. Let me go to this one. To check the changes, we need to get the variance or a standard deviation. Okay, so we can calculate the standard deviation of these ranges for the, for example, for New England. Dataset 2. First we need to, or we can just simply use this formula, like variance that equals variance of sample or population. We define this range. This is going to be the variance for New England, and we can calculate variance for other regions like Middle Atlantic. Again, variance that equals var for this range, and the same for the other region, and then compare these values. This way we can answer to the second part. In which region of the country have gasoline price changed the most? By checking the variance. In which region of the country have the gasoline price remained relatively stable? With the same thing. And we can also plot it in a line graph to see the variance, the changes of the variable. Any question from question 3? So for this question, you need to calculate the variance of the regions.